Alright, so this is 12-2 on translations, and if you remember, a translation is just a slide. It doesn't flip or rotate or anything like that. And there's two ways to do it. Some of you like the algebraic formula, so I'm going to show you that way. That's called coordinate notation. And some of you like to do it more visually, and I'll show you that way as well. For this first example here, we have a trapezoid. M is at the point 1,5, so I wrote that down there. N is at the point 5,5. O is at the point 4,3, and P is at 2,3. So just write down the coordinates that you have. And remember, at any point you can pause or rewind if it's going too fast for you. So this time, following the rules, all you do is take your x and turn it into x minus 2. That means you're just plugging the x in there and you're going to get a new value. Then you take your y and you turn it into y minus 3. This is just one example of what the rule could be. So you take all of your x values, all of your y values, and you plug them in. So for instance, you have 1 is your x, so I plugged it in right here. 1 minus 2, 1 minus 2. And 5 was my y, so I plugged it in right here. 5 minus 3 right there. And you do that for all of them. Take your x value and plug it in. Take your y value and plug it into this rule that's happening right here. Take whatever your x is, do minus 2. Take whatever your y is and do minus 2. And these are the values that I came up with. Now all you have to do is simplify. 1 minus 2 is negative 1. 5 minus 3 is 2. So your brand new ordered pair comes from that. You have 1 minus 2 is negative 1 and 5 minus 3 is 2. So I'm going to take that and graph it right here. M prime is going to be negative 1, comma 2. That's my M prime right there. And then N prime, I did 5 minus 2 is 3. 5 minus 3 is 2. So I graphed that point at 1, 2, 3. Here we go, 3, comma 2. That's N prime. O prime came out to 2, 0. And P prime came out to 0, 0. So that's what our new image is going to look like. And when you connect it, you can see it's the exact same shape. It hasn't flipped or turned or anything. All it did was slide down into the left. And how many? Look, right here. Take your x's. That means left or right. So when you say x minus 2, that means 2 to the left. And take your y's. That means up or down. And when you have a negative value, it means you go down. So we went down 3. So what we did right here is the exact same thing as saying go left 2 and down 3. So take this again, we'll go left 2 and then down 1, 2, 3. And you can see it comes out to the same thing. So you can either do it by calculating the values or by just determining how far you go right or left or how far you go up or down. There's one other kind of notation you need to be familiar with. It's called vector notation. Some of you will remember this from science class, especially physics. They use vector notations here. A vector is written with a pointed bracket. It's not parentheses like an ordered pair. It's a bracket, and it still uses x's and y's. Your x value will be represented up here, and your y values will be represented right here, but it's not about the location of the point. It's about the change in the point. These pointy brackets represent that there's movement going on. So look at what's happening here. If you take your x and you add 5, x means you go left or right. That's what the x-axis means, left or right. So positive means to the right, negative means to the left. So in this case, if you're going to do positive 5x plus 5, then you can put positive 5 for your change in x. And then for the y's, it means you go up or down. So y minus 4, the y-axis is going up or down. Minus 4 means it's a negative value, so that means that from wherever you are, you go downwards from there. 5, negative 4 in the movement. So to make your new graph, all you have to do is consider those points, and wherever you are, go 5 positive in the x direction, go 4 negative in the y direction. So let's start with the C here. You go 5 to the right, 1, 2, 3, 4, 5, and you go 4 down, 1, 2, 3, 4, and there's your new point right there. For your B, you go to the right 5 and down 4. right 1, 2, 3, 4, 5, and down 1, 2, 3, 4. And there you have that new point. For A, you do the same thing. Right 5, down 4. So it's 1, 2, 3, 4, 5, down 1, 2, 3, 4. And that's your new image. And that's what it looks like. And at the same time, I just want you to notice that you can take this whole triangle and you can go to the right 5. You can go 1, 2, 3, 4, 5, and then you can go down 4. 1, 2, 3, 4. And that's all that translations are. It's just sliding, no rotating or anything. So let's look at some different ways that it can look to you. It's going to be the same concept, but they might ask it in different ways, just like in all of geometry. So this time, they're going to give you a picture. It's the same idea, but they're asking you to write out the rule or the notation that actually happened. So your original one is the one without any prime letters right here, and this is your image. So this is where we started, this is where we end up. So we have to figure out what happened. So start on this point right here, this point C. And let's figure out what happened to get it up to the point C prime. Okay, figure out the change. So it looks to me like we're going to the right. That's going to be a positive value, positive change in the x's. So let's count how many places. 1, 2, 3, 4, 5. So we're going 5 to the right. That means you're going positive in the x direction 5 places. All right, now from there, 1, 2, 3, 4, 5, we have to figure out what it takes in the y value. So it looks like we're going up, 1, 2. That's a positive value also for the y's because you're going in the positive up direction. And from this picture to this picture, that's the rule that happened. In order to write it as a vector, all you do is write what the changed part was. The x's, from the x's we went positive 5, and then for the y's we went positive 2. So that just means right 2, up 2. And that's the same thing. Look at the b. You go 1, 2, 3, 4, 5 up, or sorry, to the right, and then 2 up, and you get the same thing. And that's the same for all the points. The A is going to be right 5, 1, 2, 3, 4, 5, and up 2. All right, and the next examples. Number 4. This time they didn't give you a picture, they just gave you all the coordinates. And these are good questions for them to ask you on tests and quizzes, so make sure that you really understand how this works. And you have to know your positives and negatives in your algebra before you can do these. We're going to write this in coordinate notation. I'm also going to show it in vector notation. But let's look at what's happening. The point A is 3, 6. It is going to become A prime, 1, 2. So I'm going to write this slightly differently so you could see it better. Right down here, I want you to think about what has to happen in order for 3, 6 to turn into 1, 2. So for your 3's, you're starting out bigger and you're getting smaller, so you're going to have to subtract. So how much do you subtract? 3 minus what would make 1? Seems like that would be minus 2. So put minus 2 here. And see, 3 minus 2 becomes 1. Well, think about the same thing for the y's. You're starting off with 6. You want to turn into 2. And in order for that to happen, you have to subtract 4 to make that happen. So it's 3 minus 2 is 1. 6 minus 4 is 2. And that takes your A and turns into your A prime. And if you're taking a test or quiz and you want to do it in a visual way, you can just graph all this on graph paper and look and count right, left, or whatever happened. All right, well, let's make sure that we did this right by checking all of the 3 coordinates here. So this -2, -4 has to work for all of them in order for it to be true. So let's check right here. 1 minus 2 becomes -1. That's good. 0 minus 4 becomes -4. That one's good. Let's try it here also. 4 minus 2 becomes 2. 8 minus 4 becomes 4. That means this vector is correct. So you can write it in vector notation. You can also write it in coordinate notation. by saying what x and y was and what it will become. Here's your x, here's your y. Okay, and then they draw an arrow to show what it's going to become. So all you have to do is write your x and then write what happened. We're taking 2 away, so it becomes x minus 2. That means on the graph you would go 2 to the left. And when your y value is -4, it means you're going down, so you just take y minus 4, and that is your coordinate notation as well. Be familiar with both. All right, let's do the same thing with number 5. Go ahead and hit pause and try this one on your own, and then when you hit play, you can check your work. Okay, so checking your work, you should have tried to turn a, which is -6, -2, into a prime, which is -3, -5. And in order to make that happen, you would have to add this time, because it takes a +3 in order to turn -6 into -3. So -6 plus +3 equals -3. Now think about what's happening here. -2, and you're going to go more into the negative direction, so you have to use a negative number to get there. -2 minus 3 would make -5, and that should work. Let's try it with all 3 points to make sure that that's the case. There it is. Okay, so now we try it here. -5 plus 3 makes -2. 3 minus 3 makes 0. That one worked. And try it over here. 1 plus 3 makes 4. -1 minus 3 makes -4. So that one worked as well. So this is our vector notation, and it worked. Now to do our coordinate notation, all we have to do is write it out as x's and y's. So x comma y becomes, hopefully you're just checking your work because you already tried it. It means that your x, your original x, turned into x plus 3, which means that you're going to the right 3 places. And then your y, your original y, turned into y minus 3, which means that technically you're going down 3, to the right 3 and down 3. So this is vector notation. This is coordinate notation. Be familiar with both ways. And the last two we're going to do here, these are the answers. The last two we're going to do here are similar. Write a rule, this is coordinate notation, this is vector notation, that describes the translation of a point from -2, 1 to become -5, -1. Okay, so think about -2 has to become -5, so it might be easier if you rewrite it down here so you can really think about what's happening. Whoops. In order for -2 to turn into -5, what you have to be doing is going -3. -2 minus 3 makes -5. So what that means is we have -3 here and we have -3 here. Both notations. But for the y, what has to happen to turn it into -1, you have to go in the negative direction. So it really takes -2. You have 1 minus 2 becomes -1. So that means our y value, you take 2 away from y, or else you think about moving it in the down 2 direction, and that's your answer. Either way. And for the last one, number 7, you have to be careful because they always try to throw in a couple to trick you, to see if you not only understand the concept, but if you can think things through as well. So here's the original triangle. A, -3, 8, B is 4, -1, C is 0, -5. And now the rule is it's translated 5 units down and 2 units left. Don't be the person that just rushes through it. Think about it. What does 5 units down really mean? Okay, let me ask it this way. which letter represents down? Is that the X or is that the Y? This is the Y value. 5 units down goes over here. Down means you're taking it away from the Y's. X means right or left, not up or down. Then when they say 2 units left, that one represents the X's. And you're taking 2 away, left means going negative. So if you write it as a vector, it's -2, comma, -5. So you could either plug in the values here to figure out what A, B, and C are, or you can use vector notation and you can just subtract it in your mind as well. Let's do it that way. I like vectors better, but if you like the formula, then just plug all your numbers in. So what we're going to do is use this every time. -3 and 8 is our original problem. We are going to use that, and our answer is going to be -3 minus 2 is going to be A prime, which comes out to be -5 for the X's, and then do your Y's. It's 8 minus 5 is 3. So that's your new value, A prime. For your B's, you just do the same rule. Okay, do the same thing every single time. So for the B prime, you take your original B and you subtract 2. 4 minus 2 is 2. And -1 minus 5 is -6. So there's your new answer for B. And you do the same thing for C. C is 0, -5. To turn it into C prime, all you do is arithmetic. 0 minus 2 becomes -2. And -5 and -5 actually becomes -10. So those are your 3 new values right there. When you come back, or when you come to class tomorrow, we're going to be looking at the examples on the back of your notes. So write down any questions that came to mind while you're watching this video, and I'll help you with anything that you need help with before we go on tomorrow. See you later.